let's look at question number 4 from the 2025 AP Calculus exam. This is a common question with AB and BC. I have not read the question yet. You get to see me solve this in real time with no rehearsal, so I will possibly make a mistake, and if I do, please point it out in the comments. The only thing I have done with this question so far is glanced at it to know that this is indeed a common question to AB and BC. So let's get started. By the way, this is a non-calculated question, so keep that in mind. And oh good, a fundamental theorem question. I just did this with my students last week. Hopefully they got it all right. Yay! So we have a continuous function on -6 to 12. F has two semicircles, a line segment. Oh my gosh, my students better have gotten every bit of this one right. Every bit. I was like, I like these questions. They're pretty common. I'm gonna do it. All right, so g of x is an integral defined function. It is the antiderivative from 6 to x of f of t dt. And when I see that, I'm going to go ahead and find the derivative of that because it is almost certainly going to come into play. G prime of x will be f of x. And I like to write times 1. You always want to multiply by the derivative of the thing that replaced the t. And it asked me to find g prime of 8, and there we go. So right off the bat, we need that g prime expression. So I'm going to rewrite in my question A field that g prime of x is indeed equal to f of x, even though I already have it written up there. And that means that g prime, not f prime, g prime of 8 is equal to f of 8, and f is the graph that is given, and the y coordinate when x is 8 is 1, and we are done with part A. That was nice. On to B. Find the value of x on the interval -6 to 12 at which g has an inflection point. Okay, inflection points are where your, oh my gosh, we did a question exactly like this last week. This is exciting. My students. So I need an inflection point. That is when g double prime changes sign. So g double prime of x is equal to f prime of x, and I need g double prime to change signs. That's what creates an inflection point, but I need to make my explanation connect to the function f. Okay, I just had a student come in to make up a quiz, so I got interrupted there. So we were talking about inflection points, and I'm going to type out my explanation here because it's just easier for me to type. Okay, g has inflection points whenever g double prime changes signs. So that is also when f prime changes signs. And now I need to connect my thought process to the graph of f, because f is literally the graph they gave us. I can't say g double prime changes signs or f prime changes signs. I have to connect it to f of x. So now I'm thinking, if f prime changes signs, what does that mean for the function f? And well, if a derivative changes signs, that means your original function f has a local max or min. So I'm going to say this occurs whenever the graph of f, which is given, has local, or I'll say relative. Therefore, g has inflection points at x equals, and let's see, we're on all values of x from -6 to 12. That would occur at -3, +3, and at 6. -3, x equals 3, and x equals 6. Now, some people may have an issue with me including 6 because there is a cusp there, right? And some people are thinking, hey, that's non-differentiable and all that mess. However, it is still a local minimum, and so we will include that. So we have 3 inflection points, and there is our explanation. Let's go on to C. Find g of 12 and g of 0 and label your answers. Okay, I think I know what they mean. They just don't want you to have floating values without it being connected. So C, I'll do g of 12 first. G of 12 is going to be, now we're going back to the function g, that's going to be the integral from 6 to 12 of the function f of x dx. And I'll say f of t, it doesn't really matter, but I'll write f of t dt, and that is a triangle, and the area of that triangle from 6 to 12, that has a base of 6, so half of 6, and the height of that triangle is 3. And that's 9, but you don't need to clean up answers, so I'm going to cross that out. And that is labeled because you see that I do have a string of equality here. G of 12 is equal to this, is equal to that, is equal to 9. So I do have G of 12 equals 9, but if you want to rewrite it, you can. All right, on to g of settle. G of 0 would be the integral from 6 to 0, and you have to be careful with this because that is a negative direction. We are traveling from right to left, which means your dt is negative. Your dt is negative, so the graph from 6 to 0 is above the x-axis. However, since we are traveling from right to left, we will give this a negative value, and that is a half a circle, so that'll be 1/2 negative half of pi times r, and the radius of that circle is 3 squared, which if you really want to, you can call that negative 9 pi over 2, but again, don't need to clean that up. And number D, find the x at which g attains its absolute minimum on the, didn't we have an extreme value theorem question already? Two extreme value theorem questions? That's fun. All right, number D. G attains its absolute min on a closed interval. This is indeed extreme value theorem, and the first thing we need to do is consider critical numbers. So I'm going to write down g prime of x, which is f of x, is going to equal 0 at the x values of -6, 0, and 6. And to test those candidates, we also have an endpoint of 12. We need to evaluate g of -6, g of 0, g of 6, and g of 12. Go back and reread the question. It says, at what value x does it occur? G of -6, we haven't figured that out yet. That will be the integral from from 6 to -6. Oh, this is nice. Of f of x dx. And the reason this is nice is I'm looking at the graph of f. I'm going to write f of t. Doesn't really matter. But if you look at the graph of f, from 6 to -6, we have two semicircles with the same radius. One's above the x-axis, one's below the x-axis. Those will cancel each other out as far as area accumulation, and g of -6 will be 0. G of 0 we already evaluated in part C, and at this point, maybe that negative 9 pi over 2 is going to come in handy. So I'm going to use the negative 9 pi over 2. I can still read it up there. G of +6 is going to be the integral from 6 to 6. That would be 0. I guess I'll write that. The integral from 6 to 6. If you don't go anywhere, you do not accumulate to any area. And so that is also 0. And then G of 12 we have already evaluated to be 9. And the question is asking for the absolute minimum. And so I would say that G achieves its absolute minimum, and they do very clearly ask for the x coordinate. So I'll type this out. G achieves its absolute minimum at x equals, and that was at 0. At x equals 0. Return that. And I think I'm done. Number 4. That is it. So I'm happy with my number 4. If you see any mistakes, comment below, and I'm off to do number 5.